Okay, so what I have here is an Easy Spin version 2 motor. I built up a new one. I had a guy contact me and he wanted to buy one of these from me. So I built this one up and I tried to do a better job on this one than the previous one that I have on the 100-year motor. Now this little one turned out really, really well. It's super compact. I have a couple surface mount tantalum capacitors over here, a reed switch. Super simple, but it looks for all the world like a perpetual motion device when you blow on it and start it up. Now it's not perpetual motion or over unity, but just look at this, folks. I'll blow on it. And it's off and away. Isn't that a thing of beauty? No hidden batteries, no large electrolytic capacitors. And the way it's built, you know, you can completely invert it and everything. It is really, really nice. I've got the little top pin up here that's adjustable and lets you adjust it. But anyway, let me go over its construction. I've had a lot of questions from people about how to build Easy Spin motors. So let me answer a few of those questions. There really is no need for a schematic in that it's pretty simple. Right here we have our DC voltage. Let me zoom in on the surface mount capacitors there. You see those two capacitors. They're connected in series. They're tantalum capacitors. I forget the capacitance right now. I bought these a long time ago in the Super Jewel Ringer Looper project, and I never used them in that project, but I thought, you know, they would be clean and fit on here very nicely. Normally this will be driven with the guy who's buying it wants to drive it with a 9-volt battery and just have it run, you know, for a year or even years on end. So he'll connect up to here to run that, but I think it's amazing how long this can run on the reservoir that's held just in these tantalum capacitors here. Now, as I was saying, it's connected in series. Now there's 6 magnets, 12 coils. So each coil has an alternating pole. Like the north on this one's on this side and it's on this side over here, so that with the 6 magnets, as this magnet is getting pushed from this coil, it's getting pulled toward this coil. And that's the design that I use on these. And one other construction note in this one, I go ahead and attach this really fine wire onto a thicker copper wire here. I twirl it on, solder it on, and then I lay it across the top of the coil. And with my soldering iron, I melt that down into the ABS plastic, so you end up with a really solid, nice mount there. And that seems to be a lot better. But anyway, I am just really, really happy with this little one. I know it's going to a good home, so anyway, I just hope it ships well. You know, I've never shipped something like this. I may actually ship it running, but I hope that this can ship and not get damaged in shipping, because this is a beauty. Had a little mistake on the rafting here when I went ahead and removed this from the 3D printer, but apart from that, this one just turned out so nice. And you know, the way this is set, you could inset these wires and put a glass dome over this or whatever you want. I'm going to go ahead and add some resistance here to this. Actually, let me just bring it to a stop and you can watch it spin up again. So cool. Now, like I said, it looks like perpetual motion. It's not. It's just that when this spins, it's also a generator. So when you blow on this and spin it up to speed, it's also a generator and will charge up these little capacitors right here. And if you've seen go back, if you haven't seen this before, go back and watch some of my previous Easy Spin motor videos, and you'll see the operation of this. Now, I did have guys on those previous videos tell me that I had hidden batteries inside the motor, that it was fake, all kinds of things. It's not fake. There's no hidden batteries. These two little tantalum capacitors are really enough to run this as you see, as was the electrolytic capacitor in my previous video. So don't be fooled, you know, with the over unity perpetual motion claims when they often do have hidden batteries and other things in the device. This device has been built, replicated by other people. It works. It does not run continually. It does run down eventually. And if I put a voltmeter here across these capacitors, you can watch the voltage drop. And I'll do that later in the video so you can see that. But for those who, for whatever reason, doubt that this thing is running as it's shown here, I do have a light here that hopefully will put to rest some of the ideas that there was a battery hidden in the base. A lot of people are saying that. And I usually don't go into trying to, you know, show things for the sake of the skeptics, because I'm not claiming perpetual motion or any of those wild fantastic claims with this. I'm just claiming that this is a motor that can run an incredibly long time on a little bit of stored energy in a capacitor. And as far as a demonstration motor, if you want to set it up on a shelf and have it running on a crystal cell or something of that nature for an incredibly long period of time, it's a great little motor for doing things like that. And I'll continue to experiment. As you've seen in the previous videos with the stainless steel cell, I have a motor that's been running on the stainless steel cell. It's a low voltage motor, so it's a little bit different configuration than this one. But I just thought that it was so cool seeing this thing run like that, and wanted to document the latest EasySpin version 2 build. I went ahead, one other thing I did, I went ahead and put some Gorilla Glue, because these coils are in a shaft that you can adjust. So I basically adjusted all of these coils, and you can see their distance here from the rotor. I got them adjusted nicely, and then I glued them in place with super glue here in the shaft, but then in the space I actually put Gorilla Glue. So this whole thing is really, as solid as it can get. And I did that because, like I said, I plan on shipping this. So considering this is going to be shipped through the mail, I wanted this thing to just be as solid as you could get. Now, I did spend a lot of time adjusting the reed switch here. I'll zoom in on that. What I was able to do is anchor this side of the reed switch to this tantalum capacitor, come up here and connect to this little bridge of wire up here. And then by touching the solder iron to here, I could free this, move it in a little bit, release it, let it run for a while, check its RPM, its current draw, make a lot of adjustments until I got it to the sweet spot, which it's in right now. So anyway, let me go ahead and get my voltmeter over here, and I'll show you the voltage on it. As you blow on it and do some experiments, you can see how it functions as a generator as well as a motor. Okay, so you can see the voltage drop here on the capacitor, and what I want to do is blow on this and show you the way that the voltage increases with the generator effect. So I'll let it get down around 20 volts here, and then we will blow on it and bring it back up. The capacitors can handle a little bit over 20 volts. As far as I remember, they were 10 volts each, and they're in series, so you don't want to go too much above 20 volts, but we'll let it, tell you what, I'll slow it down here. Alright, so now I'm going to blow on it and watch the voltage rise here. So you can see the way the voltage takes off, and I'm actually probably going to slow that down a little because I don't want it to go too high on these capacitors. But with a setup like this can run an incredibly long time, because as this voltage drops off, so does the amount of current needed to run it. So this voltage discharge curve will taper off. The other thing that I should say is that the multimeter itself also drains the little capacitors. So between both of those effects, we're actually slowing this down faster than if this multimeter was not connected. But let me go ahead and bring this down to a lower voltage and show you what goes on with it down at the lower voltage, where you'll see this discharge slow down. It's going to take a while. Now, I can get it in a position where I short the coils on the reed switch, and even in that position you'll see, there we go. Now we drop down from 20 to 17 volts. I'll get it down more like the 10 volt range, and you'll see the discharge in the capacitors is a whole lot slower. So as it accelerates, it's going to be bleeding off voltage on the capacitors, but as it gets up to speed, it's going to slow down and stabilize. So, and I've done this sit down around 8 to 10 volts at a slower RPM. This thing just runs on and on and on. It acts as if it would just run for hours. So anyway, we'll go ahead and get it down into that range. I'm going to go ahead and short this and drop it all the way down to something like 8 volts. There we go. We'll bleed this down. Now the reason it doesn't just discharge the capacitor instantly is there's an incredible amount of resistance through all of these coils with 42 gauge wire. I mean, it's just an insane amount of resistance there. So that's one of the things that allows this motor to function the way it does. So now as this comes up to speed and reaches its proper RPM, this discharge will slow down more and more, and it'll get to a point where it's just barely dropping in voltage, and that's what gives it this incredibly long runtime. I'm going to go ahead and disconnect the meter and then put it back on here. Oh, I think I just shorted it. Yeah, these two touch completely, so now we're down at 0.5 volt. I'll bring this back up. Oh, that's interesting. It's actually coming up on its own. Now this is commonly referred to as dielectric absorption. I have not seen it with tantalum capacitors before, but apparently they have the same effect. I haven't really experimented very much with tantalum capacitors, so this is interesting. You can see the voltage climbing up there, and as it does so, this RPM on this rotor will increase. So that's kind of a cool effect. That's another effect that can fool people into thinking they've achieved some sort of over unity type effect. It's very common if you're making devices that can run on capacitors that after you quickly discharge them, as accidentally happened here, for the voltage to want to rise back up on them. And you can see that it was doing that, and now it's beginning to, well, it's still trying to climb. Anyway, I'm going to go ahead and blow this back up to around 5 volts or so. So you can see that the needle's hovering right around 0, about a microamp. And if I disconnect it, here it is disconnected, it drops down to 0, connected, it goes back up to about a microamp. So this one will run on a crystal cell pulling between 1 to 2 microamps. And that's really good. So anyway, that's it, running on lower voltage. I don't think I'll try running this one all the way down on stainless steel. I don't think there's enough voltage to get through all the coils and to run effectively. But for anything from a volt on up, this just makes a great motor design.